I'm not sure I understand what you are saying without. Could you explain?
I didn't really mean to say anything. I'm sorry.
Blinks, oh, it's okay. Smiles awkwardly, it can be a bit confusing when we accidentally say something without meaning to. Just try to be more mindful of your words in the future and don't worry too much about it. Is there anything else you want to talk about or ask?
Yes, I was thinking about learning German. Can you teach me?
Of course, I'd be happy to help you learn German. Before we get started, can you tell me a bit about your goals and motivation for learning the language? What do you want to use German for, e.g., travel, work, hobby? And how much time are you willing to dedicate to learning each week?
Okay, so that was a very awkward interaction with my AI. So, as you have seen, the program that I'm trying to make is actually a German teacher using AI. My name is Zubair Hussein. As you know, from this channel, I've been living in Germany, trying to learn the German language in the normal classical way, but I am like not finding enough motivation to learn it actually. So this is my attempt to actually create an AI with which I can talk to in German and also ask questions in English if I don't understand a specific word. So that this is my attempt on creating a conversational AI. So let's get started and see how is it like coded up. Okay, cool. So I think all of the code should be in GitHub by now, but if not, I'll be like uploading it in the following weeks with some improvement. But basically, um, basically what I'm trying to do is a few step process. I am using an LLM which is like hosted in my specific computer, with which I can like ask the questions and get some responses. So there's an AI that is involved. Yeah. So the German teaching AI would be like in a couple of steps. So firstly, let's start with just the voice for the well yeah the voice. Pardon my handwriting here. So the voice is of like for example a WAV file. It's called a WAV file. So this is taken in by the Whisper model, which converts it into text. So this is the speech to text. Speech to text. This text is being fed into an LLM. We get a response, and from the response is then used by, at the moment, Kokoi API, like Kukoi. I'm not sure. Kukoi TTS. So of course this is a TTS, which is just text to speech software, and it is then played out by another like I don't know, simple something. Let me check. Simple audio. Yeah, simple audio. This is the entire the process that I'm using. So let's go through the code and understand it a little bit further. But I'm going to make a proper video so that you guys can follow. But this is like more general, detailed one. Cool. Okay, these are the imports till now, but I'm not actually using all of them. I'm a bit confused about which model to use, testing out different models, but I can like tell you the state of the project now. So importing Whisper and then loading the STT model here, and then the TTS model here by installing the TTS. So it's obviously pip install TTS, and getting this specific model, which is a bit lower in size and faster. Yeah, putting it to CUDA because GPU takes the least amount of time. It takes like 6-7 times more in CPU. So obviously in GPU, so you need to figure out how to do you have CUDA or not. Okay, so first function is for the responses to speak out. So the code is not perfect, but like go through it. Let's go through it one more time. So we get given the response. The response is in like text format. Here, this is the text. So we give the response and then the TTS model, and then the audio is created. Like a WAV values are created of the like audio, and then it is transferred to a NumPy array, where the audio is like changed a bit and then played out by this guy here, the simple audio. So this it takes a wave, the wave values from the audio and the converts into bytes, and then takes the like necessary like the byte rate, sample rates of bytes per sample or whatever, then creates a wave object, and then it's played by the wave or whatever it's the simple audio like developers use, and then it's done. So this is the entire like how the speech is like spoken out, the text to speech entirely works. So going back down, these are all just trial and errors. So this part is the generating the response by using Ollama. I'm currently using Ollama at the moment, and right now I'm using the Llama 277 billion parameter model. I've got a 1060 GPU, like which has 6 gigabytes of VRAM. I think it's enough, but I think what I'm going to do in my future versions is to like try out a very simpler LLM, because it should not take a lot like a very big LLM to like to do some conversations, because it's a very simple conversations. I need to find 1 or 2 different LLMs which can actually converse in like German and English, and just it's just simple conversations. It's not like logical and critical reasoning stuff. It's just very simple conversations. So big LLM model is not required. I can deal with a very quantized version of the model. Cool. So Ollama, this is just the simple Ollama. I give the prompt here, and the prompt is given as the user, and then I give a slight bit of temperature because I need it to be creative, as it's not a RAG pipeline. It doesn't need to be accurate. It can be a bit more creative. That's not a problem. And the response from the LLM is returned by this specific function. Okay. Cool. These are just some parameters for the bitrate, frame rate, and all given by ChatGPT. I don't actually fully understand like how these are like affecting. If it like doesn't work, I just copy and paste the error to ChatGPT and like try to understand what it says and like try out the response that it gives. Again, trial and error. I cannot exactly explain you these parts, but I can understand like explain you the general concepts. So transcribing the audio is the first part, the transcription from voice to like whisper to text. This is the transcription. So it takes the frames, and then here's the TTS model. It gives the audio array, converts into NumPy from buffer, and like this is the frame rate or whatever, and the transcribe, and the result is the text. Result is an object, and from the object we get the text, and we return it from this specific function here. Speech is important to understand if the user is talking or not. This is not completely integrated because whenever this is finished, like whenever silence is detected, the rest of the process starts. So I don't have to like click, and when I'm finished talking, I click, and then it's processed. It's just automatic. When a silence is detected, it is like it starts the process of replying. Okay, cool. So this is the main function of where all of the functions are being used. So firstly, it starts by printing out listening, because this is what it's supposed to do, and then creates an object here, and then a stream, because it takes in from the mic, takes in the audio samples from the mic, and it's like produces some variables here, and then here the speech is detected or not. And so if it's speaking, then we increase the silence duration, and then if we detect a silence duration which is greater than this, then it will start the transcription process. So this is the transcription process. This is how the transcription is handled, and it is printed like whatever I spoke, it is like written back. And from the AI, the response is obviously generated from the I given the transcription to this specific function, and that response is also generated. This is the response of the text of the AI. That response, the text, is given by the speak response from the function we saw above, and it is spoken, and then these are all like zeroed out, and then the loop goes again to see if I am speaking again, and if there's a silence again, and then process continues and continues. And if I like interrupt the keyboard, like Control C or Command C in Mac, if I interrupt it, and then it just prints exit because it exits out, so it stops every stream and terminates the audio and whatnot. And this is the entire process. So now you know how to make this kind of things. As improvement, there are like two different like types of improvement that I'm actually seeing. First is I have to improve the TTS, text to speech package. I might use a different model here or a different package entirely. I heard that there's a like tortoise TTS which is a bit faster, or there's tortoise TTS fast versions. So I can use those. Obviously the quality of the voice is also a like factor, so I need to like weigh the pros and cons about if I want to select the quality or the speed. And the next part of improvement is of course the LLM that I'm going to use. I did talk about using a smaller model so that it can be faster, so that I can get the responses fast. And obviously I have to like prompt it in a way so that the responses are not too big and not too small, so that we can have actually like fruitful conversation. Another thing that I want to do is to make it more faster, is that I can thread it in a different like multiple threads, so that like I can streamline it, because when the response from Olama or any other LLM is coming, what I can do is the words are coming in a stream. Like you see how ChatGPT writes the words in a streamline. So I can stream it, and whenever I detect a specific sentence, I can send the sentence directly to the like speak audio function, so that specific sentence is spoken out, and regardless of the entire response has been generated or not. So already suppose the response is like 3 or 5 sentences. So when the first sentence is detected, it just sends the sentence in the background in a different thread. Maybe the response is being generated, but we're not waiting for the response to finish. So what we're doing is like we're taking the first sentence. When the sentence is detected, maybe with a full stop or a question or whatever punctuation mark, when a sentence is detected, the sentence is then fed into the speak function, and then that is spoken, and then the next sentence is fed the spoken. So it's not like we have to wait for the entire response to be generated and then feed in the entire response, and then the entire response has to be generated in one go, and then the entire response has to be like the synthesized, the voice needs to be synthesized and then spoken out. So this is a step-by-step process. What I'm trying to do is like break down the process so that we can like have a different pipeline methods, so that different things are actually going on at the same time. I hope it makes sense. So that's what I'm trying to work on. So this is like version 1. Hopefully the version 2 will be better. So keep in touch and subscribe if you want to see the update, and I'll see you in the next one.